Hey guys, welcome to another video by Supernal Tutorials. In this video we'll be focusing on calculus differentiation. So on our question we're given a function and asked to determine the first derivative from first principles. So when solving a differentiation question on first principles, you actually need to know the formula, and the formula is as follows. You don't really need to know much about the limit here and the h approaching 0. You just need to know how the formula works. Don't stress much about how it came about. You just need to know how to apply it. So okay, when dealing with such a question, I always suggest that you do it on a rough piece of paper and actually use the easier way of differentiation. Okay, let me first write down the function here. So by other means of differentiation, you know that we actually take down the power, we take it to the base, so it's going to be 2x, and then we go to the power and we subtract 1, and then we do the same this side, right? So this is 3x, it's the same as 3x to the power of 1, so we take down 1 to the base, it's going to be 3 times 1, so it's actually 3, right? And then multiplied by x to the power of 1 minus 1. As we did here, we said 2 minus 1. We're going to do the same here and say 1 minus 1. We subtract 1 from each power. Yeah. So yeah, it's going to be like this. 2 minus 1, it's going to be 2x to the power of 1. So yeah, that's how it is right there. And then we have 3x to the power of 1 minus 1. So it's going to be x to the power of 0. Any variable to the power of 0 or any number to the power of 0, it's going to give us a 1. So this is going to be 3 times 1, because any variable raised to the power of 0, it's 1. So yeah, it's going to just be 3. So this is what we expect to get when we carry out the differentiation from first principles, right? So this is just a quick way of trying to confirm your work. You need to know that by the end of your calculation, this is what we need to get using first principles. So yeah, now let's get back to the first principles, right? So we're gonna calculate fx plus h. Fx plus h. I know sometimes people struggle to understand what the notation means, right? So this is f, right? And this represents the substitution part, right? So this is what we substitute right into the function, right? So this means that at x we're going to substitute in x plus h. So x plus h to the power of 2 minus 3 x plus h, because we also had an x right here, so we substitute in x plus h. So this is going to give us, we're going to expand this. I hope that you'll know how to do this, so you don't really have to say much about it. Simple as that. Then I'm actually running out of space, so let me just switch on to the next page before I confuse you. So on the previous page we had calculated fx plus h, and it gave us x squared plus 2xh plus h squared minus 3x minus 3h, right? So we're going to substitute this into the formula for first derivative. Okay, wait, let me first write down the formula again so that people can understand better. So yeah, this is how it's going to be. This is fx plus h. Then we also had fx, which was our given function. Fx was equals to x to the power of 2 minus 3x, right? Without okay, wait, let me first write this down. Without adding a lot of unnecessary steps, right, we can tell that, okay, this is going to give us a negative x squared, right? So a negative x squared and a positive x squared, they're going to cancel out, and then we're going to have a positive x to the power of 3, right? And we have a negative x3, right? So a negative x3, a positive x3, right? So they're going to cancel out. Then we're going to be left with 2xh plus h squared minus 3h over h. I'm sure you can tell that we have h in common on both sides, so we can factor out the h. We all know factorization, of course. So the h will cancel out. Then we're going to be left with this 2x plus h minus 3, right? So at this step we can actually substitute in h is equals to 0 to get our first derivative. When you substitute x is equals to 0, I mean h is equals to 0, you don't include this part here. You remove it from your final step. So this is going to be our first derivative calculation based on first principles. So as you can see, this answer is the same that we got using the easier way of differentiation, right? Okay, yeah, this will be all for our first question. For our second question, this is what we have. So again, sometimes some people struggle with actually understanding what is being asked. So I'm going to explain the notation, right? This is dy over dx. This means differentiation of y in terms of x, right? So we're going to differentiate y, which is a function, right, in terms of x, which is the variable, right? Yeah, so differentiating y in terms of x, that's what this means. Yeah, okay, so looking at y, we wouldn't, it's not easy to actually differentiate right from word go, right? So we're gonna expand this and make it a little bit simpler, right? Let's expand. We all know expansion, right? So this is going to be x to the power of 4 . Okay, let me write it down. It's going to be simpler this way. So yeah, I just said x squared multiplied by x squared. It's going to be x to the power of 4, and then x squared multiplied by minus 1 over x squared. This is what I wrote, right? And then minus 1 over x squared multiplied by x squared. So this is what I wrote. And then minus 1 over x squared multiplied by minus 1 over x squared. This is going to give us a positive. right? And then 1 over x to the power of 4, right? So as you can see here, these ones will cancel out. Then we're going to have x to the 4 minus, we're left with 1 here, -1, -1, so it's -2, right? Then plus 1 over x to the 4, right? And then this is going to be our expanded form of y, right? And then this is what we're going to take and we're going to differentiate, right? Okay, let me first, when we have a fraction like this, it's best that you invert the fraction and you put it as in the following way. When you invert it, it's gonna be when you take this up there, it's gonna get a negative power, so -4, right? As you know, x to the -1 is equals to 1 over x. So yeah, this is what I applied to invert this one right here. So yes, differentiation of y in terms of x is going to be equals to the following, right? As you know, we take the power to the base, so it's going to be this power to the base, so it's going to be 4, right? X, and then we subtract 1 from the power, so 4 minus 1, right? And then in this case here, we don't have a variable x, so it's a constant 2. A differentiation of a constant gives us 0, so this is going to be -0, right? And then we come to this one, we take down the power, it's going to be -4, right? X, -1, we subtract 1 from the power, -1. And then, okay, let's rewrite this in a better way, simplified way. It's going to be 4x to the 3, right, minus 4x to the -5. If you want, you can still put it in this form. So in this way, you've actually differentiated y in terms of x. This will be all for this question. So for our third question, this is what we have. So again, you need to first understand what is being asked. So it says dx. Dx means differentiation in terms of x. So with differentiating what is within the bracket in terms of x, right? Okay, so looking at this, you cannot just differentiate straightforward from this. So we actually need to simplify this first, right? Okay, let me first focus on what we have within the brackets, right? And let's simplify it. When you simplify this, let's first factorize that, right? I hope you all know how to factorize a cube root. If you don't, we're actually gonna need to check a YouTube video or something of how to actually differentiate this, but let me try to explain as best as I can, right? Okay, so we have 3 to the power, x to the power of 3 minus 1, right? So for the first bracket, we say x to the 3, we find the cube root of this. A cube root would mean that we actually putting this under cube root like this. So in such a case, these would cancel out and we will be left with x. This is what we get, right? And then putting a 1 under a cube root gives us 1. So that's why we have -1 right here, right? And then for the first term of our second bracket, we square this. We square x. And then for the following part, we multiply these two. So x multiplied by -1, it gives us a negative x. But as a rule, we oppose the sign, so it's going to be a positive x. And then for the last part of our bracket, we square this, so -1 squared, that gives us a positive 1, right? Then as a denominator, we had x minus 1, and then these two cancel out, so it means that we have this left. So this is going to be simpler in this way. So looking at this, it's easier to differentiate that. So to differentiate this, we're gonna take down the power, so it's going to be 2x, right? And then x to the 2 minus 1. We subtract 1 from the power as always, and then from this we take the this is x to the power of 1, so we take down the base. It's going to be 1 multiplied by x to the power of 1 minus 1. So just think that we have 1 right here. Doesn't really change much. So yeah, and then this is a constant 1. A derivative of a constant, or rather differentiating a constant, gives us 0, so plus 0. So we simplify this and we done. X to the 0 gives us 1. Any variable to the power of 0 or any number to the power of 0 gives us a 1. So yeah, this is what we have as our final answer, and in this way we have actually solved the question. Thank you for watching this video. Please comment and tag your friends, and yeah.